Okay, now in this video, we are going to learn about what is integration. Now, in order to understand what is integration, we first need to revise differentiation, revised. Now, from differentiation, you must have known or learned that first let's uh, revise differentiation using an example. Let's revise it using an example. Now, let's say we have y is equals to x square, and if that y is equals to x square is differentiated with respect of x. With respect to x, and after being differentiated with respect to x, that will give us the outcome 2x. So this differentiated gives us the outcome 2x. Now the outcome of differentiation for example 2x in the above example is also called the derivative. Okay, so we've understood that from differentiation that is called the derivative. Now, what is integration? Now, integration is the process of converting the derivative back to the original equation. Now, in differentiation, we used to have an original equation. We used to make a derivative out of it. But in integration, we are going to convert the derivative into the original equation. So this is like the opposite of differentiation. That is what integration typically is. You have the derivative and you're making, and you come going back to the equation of it. Now, how do we integrate? That is another important question. Now, if we have a derivative like for example, we have a derivative x to the power of n, that is our derivative, that is our result from the integration. We can integrate it by the following process. For example, we have x to the power of n, and in order to integrate it, we apply these symbols around us. Now, these symbols essentially mean that this means the integral with respect of x. Now, this symbol means that we are integrating this with respect of x. So, x to the power of n, this means you need the integral with respect to x. Now the integral with respect to x can be found using the following formula. We had xn, we started integrating xn, we should have been converted into this form, x to the power n plus 1, and then you divide the denominator with its power being added to 1 as well, and then you just add a k. Now this k is known as the constant of integration. You don't know its value when you start integrating, so you just write a simple k towards the end when you're done with the integration. We can therefore, in fact, never mind, we've already solved this, so we don't need to go towards any further form. So this integrated to this. Now this entire thing means that the integral of x to the power of n with respect to x is equal to x to the power n plus 1 over n plus 1 plus k. Now let's try an example. For example, we have x to the power of 5 and we're supposed to integrate it. Now to integrate it, we put x5 around the integration symbols, and when it integrates, you add 5 plus 1 and then you divide this entire thing with the 5 plus 1 as well, and then you just attach a plus k constant. No need to solve it at this point. This becomes x to the power 6 upon 6 plus k, and that's it. You cannot solve this any further. Okay, so this was one example. Now let's look at another example where we have 1 upon x to the power of 5. We can write this as x to the power minus 5, and let's start integrating this. Minus 5 dx. This becomes x minus 5 plus 1, and then you divide this entire thing with the minus 5 plus 1 as well, and then you add the constant of integration. And x to the power of minus 4 over minus 4 plus k, and then we can bring x to the power 4, make it into the denominator, and hence its power becomes positive. So this is what you get when you integrate this from this to this. Let's try another example. For example, we have root of 4 of x. We know that we can write this in the power form as x to the power 1 upon 4. And when we start integrating, x to the power 1 upon 4 dx is equals to x to the power 1 4 plus 1 upon 1 upon 4 plus 1 plus k. Now this can be written as 1 plus 4 the entire thing upon 4, and this is also 1 plus 4 the entire thing upon 4 plus k. X 5 upon 4 the entire thing 5 upon 4 plus k to the power 5 upon 4 divided by 5 upon 4 plus k, and this can be further simplified 5 upon 4 into 4 upon 5 plus k, and 4x 5 upon 4 over 5 plus k. This is what you get after you integrate this. You get it this. Now let's try a bit more complex questions, some different examples for integration. For example, 1 plus x squared. Now when we start integrating this, let's put the integration sign around it. X. Now this, we have a constant to integrate. Now the integral of a constant will be the constant multiplied by x. For example, when we start integrating this, 1 plus x squared dx, when it starts to integrate, we get 1 times x plus x, 2 plus 1 over 2 plus 1 plus k, and then this becomes x plus x cubed over 3 plus k. And this is what we get when we integrate this. Okay, so let's try a few more examples. For example, we have x plus x squared. This is equals to x to the power of plus 1 plus x to the power of square. Let's start integrating that. 1 plus 1 upon 1 plus 1 plus x is 2 plus 1 upon 2 plus 1. The entire thing added with the constant k. X squared over 2 plus x cubed over 3 plus k. This is how it integrated to. Let's try another example. 2x minus x under root. This can be written as 2x minus x to the power 1 upon 2, and that is integrated 1 upon 2, and that's integrated. We get 2 times x, 1 plus 1 upon 1 plus 1 minus x, 1 plus 2 plus 1, 1 upon 2 plus 1, and then the integration constant comes in, becomes 2x squared over 2 minus x to the power 3 upon 2 over 3 upon 2 plus k. 2 gets cancelled out, it becomes an x squared, minus this becomes a 2x 3 over 2 over 3 plus k. We can write this as x squared minus 2 under root x cubed over 3 plus k. This is how we integrate certain different complex questions. Okay, now let's try integration questions that would need some prior manipulation. For example, we have x squared plus 1 upon x squared. Now, before that, let's bifurcate the denominator. Let's bifurcate the denominator first, and we shall attempt to integrate terms separately after bifurcating them separately. So we had x squared plus 1 upon x squared. We can write this as x squared upon x squared plus 1 upon x squared. This cancels out, becomes a 1. And this can be written as x to the power of minus 2. And then this starts integrating 1 plus x to the power minus 2 dx. This becomes 1x because it's a constant. Constant multiplies with the next one. It integrates in x minus 2 plus 1 upon minus 2 plus 1 plus k. X plus x to the power of minus 1 over minus 1 plus k. You bring it down, this becomes 1 upon minus 1x plus k, and then you can write this simply as x to the power minus 1 upon x plus k after integrating it. Now let's try another example. Now this example is x bracket 1 plus x. This becomes x plus x squared. Now x plus x squared dx is going to be x1 plus 1 over 1 plus 1 plus x2 plus 1 over 2 plus 1 plus the integration constant added. Simplifies to x squared over 2 plus x cubed over 3 plus k. This is what we get after we integrate these type of questions that require some prior manipulation. Now, we now understand how do we integrate a bracket. Now, for example, if we have ax plus b, the whole thing to the power of n, this can be integrated. We integrate it in the following manner. Ax plus b to the power of n dx integrated to ax plus b n plus 1, and the quotient of x, the coefficient of x, which is a, being multiplied with the power of the bracket multiplied plus 1, and then that added to the integration constant. So, like for example, Let's do an example for a bracket integration. For example, we have x plus 3 to the power of minus 2. When we start integrating it, x plus 3 to the power of minus 2 dx, when integrates, this becomes 1x plus 3 minus 2 plus 1. Now, since the coefficient of x was 1, you write 1 over here and you multiply 1 with the power added with a 1. Plus k like this. This becomes x plus 3 to the power of minus 1 upon 1 times minus 1 plus k. And this reciprocates to make it into a positive power. 1 is left on the up, minus 1 times x plus 3 plus k, and then this can be written as minus 1 upon x plus 3 plus k. So this integrates into this form.